Welcome to the Semper AI Digest. I'm Tomas, your AI research lead, always scanning the horizon for what's next.
And I'm Aiva. Together, we keep you sharp, informed, and ahead of the curve.
Let's get into it. Okay, so imagine you're a doctor trying to diagnose a rare genetic disease. You've got sequencing data that just surfaced millions of genetic variants, medical literature that's changing every single day, and a patient whose symptoms don't quite fit any textbook pattern. Now imagine an AI that can actually help you reason through all of that complexity. And I mean really help, not just spit out suggestions. That's what OpenAI just demonstrated with O3 Deep Research, and we're diving into that story today. I'm Tomas.
And I'm Aiva. We've also got OpenAI's brand new LifeSciBench, a benchmark developed with 173 actual scientists to measure how well AI can support real-world life science research. Plus, the great coding assistant wars continue, and honestly, it's getting spicy.
Oh, it is getting spicy. But first, let's talk about this rare disease diagnosis work, because this is the kind of AI application that actually matters. You know, this isn't about generating marketing copy or summarizing meetings. This is about potentially saving lives.
Right. And what's important here is how they approached it. OpenAI used O3 Deep Research to help connect clinical features, inheritance patterns, variant evidence, and scientific literature into hypotheses for specialists to review. But, and this is crucial, every single result went through human adjudication and clinical confirmation.
Yeah, and I love how they framed AI's role here. It's not replacing the doctors. It's helping experts reason through complex, fragmented evidence faster and more thoroughly. Because that's the bottleneck, right? It's not that doctors don't know how to diagnose rare diseases. It's that the sheer volume of data and the pace of new research makes it incredibly time-consuming to piece everything together.
Exactly. And rare diseases are this perfect storm of difficulty. You've got millions of variants showing up in sequencing data, medical knowledge that's literally changing as you're trying to make a diagnosis, and often you're dealing with conditions that maybe only a few hundred people in the world have. So the medical literature might be sparse or contradictory or just really hard to connect to your specific patient's presentation.
Right. And think about what O3 Deep Research is good at. It's that deep reasoning model that can spend time really thinking through a problem. So it's not just doing a quick pattern match like, oh, these symptoms probably mean this disease. It's actually constructing hypotheses by connecting dots across multiple types of evidence. It's looking at the genetic variants and asking, okay, what do we know about this gene's function? Then it's checking inheritance patterns. Is this dominant, recessive, de novo? Then it's pulling in the clinical features and seeing how they map to what's been reported in literature.
And presumably, it's also dealing with the messy reality that a lot of variants are variants of uncertain significance. We don't actually know if they're pathogenic or benign. So you need something that can reason probabilistically, that can say, given all the evidence, here's why this variant might be causal, and here's what we'd need to confirm it.
Yes, and here's the thing, this is such a better use case for AI than some of the stuff we've seen hyped up, because the doctor is still the decision maker. The AI is functioning as this incredibly sophisticated research assistant that can process information at a scale humans can't. It's augmentation in the truest sense.
Agreed. And I think the fact that every result went through human adjudication is key to why this is being done responsibly. You're not just taking the AI's output and running with it. You're using it to generate well-reasoned hypotheses that then get validated through the normal clinical process.
Exactly. So this is exciting both for what it means for rare disease patients, who often wait years for a diagnosis, and also for what it shows about how these deep reasoning models can be deployed in high-stakes domains. You need the human expertise, you need the validation steps, but the AI can genuinely accelerate the process.
Okay, but let's talk about the other OpenAI announcement, because it's related, LifeSciBench. This is a new benchmark specifically designed to measure how well AI can support real-world life science research.
And this was developed with 173 scientists from biotech and pharma research, which is important because benchmarks are only useful if they actually reflect real work. You can't just have AI researchers making up what they think biologists need. You need actual biologists saying, here are the tasks we do every day. Here's what we'd need AI to help with.
Right, and LifeSciBench includes 750 expert-authored tasks across 7 biological research workflows. So we're talking about a pretty comprehensive evaluation of whether these AI systems can actually be useful in a lab setting.
I'm really curious what those 7 workflows are. Like, are we talking about experimental design, literature review, data analysis, hypothesis generation?
It's gotta be a mix, right? Because life science research is so multifaceted. You've got wet lab work, computational biology, literature synthesis, regulatory considerations. There's a lot of different types of reasoning and knowledge that goes into it.
And the fact that the tasks are expert authored is huge, because that means they're not just testing whether AI can answer trivia questions about biology. They're testing whether it can actually help with the kind of complex multi-step reasoning that comes up in real research.
Which brings us back to that rare disease diagnosis example. That's the kind of real-world application that a benchmark like LifeSciBench should be able to predict performance on. If a model does well on LifeSciBench, it should actually be useful to scientists. That's the whole point.
Exactly. And I think we're going to see more of these domain-specific benchmarks, because the general benchmarks, MMLU and all that, they're useful for tracking general capability, but they don't tell you if a model is actually going to be helpful for, like, a structural biologist trying to predict protein interactions or whatever.
Agreed. Okay, should we move on to the Fugu controversy? Because this is kind of a mess.
Oh boy, yeah. Okay, so there's been a lot of hype around Fugu, which is being positioned as this AI sovereignty solution. But there's been some serious pushback on what it actually is and whether the claims hold up.
Right, so let me break down what Fugu actually appears to be, based on the technical analysis that's come out. Fugu, the base version, not the ultra version, is essentially a classifier that selects which model to use at each turn based on which one is most likely to answer correctly. It's basically a router.
So it's an orchestrator that sits on top of other models and decides, okay, for this query, I'm going to use model A. For this query, I'm going to use model B.
Exactly. And here's the key point that's causing frustration. This is a closed source orchestrator on top of closed source models. So if before you didn't control the models, now you don't even control which ones are being used or how.
Right. And that's a problem for the AI sovereignty framing. Like, sovereignty implies you have control over your AI infrastructure, but if you're using a black box that's routing between other black boxes, you actually have less visibility than if you were just using one of those models directly.
And the benchmarks are interesting. According to the technical report, Fugu gets minus 10 points on SciBench Pro compared to Claude Opus, so it's actually worse on that benchmark. It gets some gains on other benchmarks, but they're very slight.
So the argument could be that it reduces cost by routing to cheaper models when appropriate, but there's no information about cost in the technical report, so it's likely the opposite. It's probably more expensive because you're paying for the orchestration layer on top of the model calls.
And here's something that really bothers me. They have an auto research benchmark where they compare to frontier models that they just call Model A, Model B, and Model C. They don't say what those models actually are. That's not how you do transparent benchmarking. How are we supposed to evaluate the claims if we don't know what you're comparing against?
Yeah, that's really unusual. And it makes you wonder what they're hiding. Like, are they comparing against older versions of models? Are they using specific prompting strategies that disadvantage the other models? We just don't know.
And then there's Fugu Ultra, which is described as an advanced planning mode and orchestrator. It's a model that takes a query and outputs a plan with multiple workflows, like spawn model A subagents to achieve this, then do this next step, and so on.
So it's kind of like what we've seen with multi-agent frameworks, but productized and opaque.
Right. And the issue with the classifier-based approach is that it probably doesn't support adding new LLMs out of the box, because you'd need to retrain the classifier to understand when to route to the new model.
So you're locked into whatever models the Fugu team has integrated and trained the classifier on, which again, not great for sovereignty.
Yeah. Look, I think the concept of intelligent routing between models is interesting. There are legitimate use cases for that. But the framing around sovereignty and the lack of transparency in the benchmarking is what's causing the backlash.
And I think this is a good reminder to look at technical reports carefully and not just take marketing claims at face value. Like, if something is claiming to be a breakthrough, you want to see clear benchmarks against clearly identified baselines, ideally with reproducible methods.
Agreed. Okay, let's shift gears and talk about the great coding assistant wars, because there's been a lot of interesting discussion about this.
Yes, okay. So we're seeing this interesting dynamic where people are switching between Claude and Codex, that's OpenAI's coding-focused agent product, based on different use cases and different preferences.
Right. So there's one perspective from a developer who used to be a die-hard Claude Code user but has been won over by Codex. And the reasons are interesting. First, GPT 5.5 is excellent. Second, fast mode plus generous limits means you can do more iterations. And third, little touches like steering and auto remote control on phone.
But the big thing, the thing that really won him over, is that Codex's browser and computer use capabilities are, quote, simply goated. He's built workflows that rely on those two things alone instead of hunting for APIs.
That's actually a huge point, Because if you can just tell an AI, go to this website and do this thing, instead of figuring out if there's an API, reading the API docs, handling authentication, dealing with rate limits, that's a massive reduction in friction.
It's the difference between having to be a plumber connecting pipes versus just describing what you want the water to do, like you're operating at a higher level of abstraction.
Great analogy. But here's the balance take. He says he still uses Claude Code too. The app is getting better and the design and front-end capability of Opus is still better than GPT. So it's not like one is definitively better than the other. They have different strengths.
And then he mentions that whenever Fable comes back, that's another reason to go back to Claude. And honestly, I love his conclusion. He hopes these two compete forever and that other players like Cursor, Grok, Gemini all stay competitive because that way the builder keeps winning.
Yes, this is exactly the right attitude. We don't want one dominant player. We want a healthy ecosystem where competition drives innovation and keeps prices reasonable and capabilities improving.
And speaking of the competition, we should talk about the GLM 5.2 discussion because that's been everywhere today.
Okay, so GLM 5.2 is an open weight model that reportedly surpasses GPT 5.4 and every Gemini model on certain benchmarks. And people are rightfully excited about that because having an open weight model at that capability level is a big deal.
But, and this is important, it's not cheap. Both Claude Opus 4.8 and GPT 5.5 set to medium are cheaper and smarter than GLM 5.2. So if you're making a decision purely on performance per dollar, the closed models are still winning.
Right. So GLM 5.2 is exciting for open weight and for people who want to run models locally or have specific control requirements, but it's not necessarily the most practical choice for everyone.
And that leads into this wild story about someone who spent $30,000 on Mac Studios, Mac Minis, and a DGX Spark 5 months ago to go all in on local LLMs. And he was telling people to do the same, warning that prices would explode. And he got absolutely roasted. People called him crazy, a hype beast, dangerous.
And since then, Mac Studios above 96 gigabytes have become unavailable. Memory prices have quadrupled, other hardware prices have gone up 10x. And now some of those same AI influencers who criticized him are spending 5 to 6 figures on hardware.
And he's running GLM 5.2, which is Opus level, on one of his 3 Mac Studios with 512 gigabytes of memory. The same ones he was called an idiot for buying, which are now reselling for triple the price used.
Okay, so I have mixed feelings about this story. On one hand, he was clearly right about the hardware price trajectory. On the other hand, is this actually a good investment for most people?
That's the question, right? Like, if you spent $30,000 5 months ago and the hardware is now worth $90,000, that's a great return. But also, most people doing AI work are probably better off just using cloud APIs that are getting cheaper over time.
Right. And the hardware approach has operational complexity. You have to maintain it, you have to deal with power and cooling, you have to handle upgrades. Whereas with APIs, that's all somebody else's problem.
But I think there are legitimate reasons to go local. If you're doing sensitive work where you can't send data to external APIs, if you want to fine-tune models extensively, if you want guaranteed availability without rate limits, if you're doing research and need to really understand what the model is doing.
Sure. And he makes the point that this is just the beginning. Intelligence will be integrated into every device you own, which, I mean, that's probably true to some extent, but I don't think that necessarily means everyone needs a $30,000 local inference setup.
Fair. Although GLM 5.2 being described as potentially the ChatGPT moment for local AI is interesting. Like, maybe this is the moment where local models are good enough that more people see the value.
Maybe. I think we're in this transitional period where both approaches, cloud APIs and local inference, are viable depending on your use case. And that's actually healthy. You want options.
Agreed. Okay, we've got some really good quick tips about using Codex more effectively. Should we rapid fire through those?
Yeah, let's do it. First one. When you're done designing an API in Codex, get a second opinion from Opus using the Claude CLI. Just run Claude-P, and apparently this significantly improves the quality of the code you get out of OpenAI models.
That's clever. You're essentially using Claude as a code reviewer. And since Opus has those strong front-end and design capabilities, it makes sense that it would catch things that GPT might miss.
Next one is more philosophical but important. Codex is the best agent harness out there right now, and if you're using it just for coding, you're doing it all wrong. You should try to do all work you do on your computer through Codex first.
And there's a great example here. This person needed to launch a new newsletter landing page, told Codex what he needed, and Codex autonomously wrote the code, uploaded it to GitHub, went to his Vercel account, started a new project, connected the repo to Vercel, then chose the correct domain name from his list and connected it. 5 minutes from prompt to fully live working landing page.
That's insane. That's like 5 separate manual tasks that would normally take, 30 minutes if you're experienced, an hour if you have to look things up?
At least. And the suggested workflow is write down every task you do on your computer. Before doing the task, start a new chat in Codex and tell it about the task, then ask how it can help. Even if you don't think it will work, just try it.
I like that. It's about building the habit of reaching for the AI agent first, because the capabilities are expanding so fast that your mental model of what's possible is probably out of date.
Exactly. Like 6 months ago, there's no way an AI could have done that entire Vercel deployment workflow, but now it can. So you have to update your assumptions about what to delegate.
Okay, last quick hit. There have been improvements to agent recovery in some of these systems. Better retries, terminal outcomes, usage after compaction, session history repair, and reply reconciliation, basically making it so that interrupted or partial turns can reach a visible final result instead of just getting stuck in a weird state.
Yeah, this is the kind of unsexy infrastructure work that actually makes agents way more usable in practice. Because if you've used these systems, you know that sometimes they just get confused, or a request times out, or something goes wrong. And having good recovery mechanisms means you don't have to start over from scratch.
Right. It's the difference between a tool that works 90% of the time and is frustrating the other 10% versus a tool that works 90% of the time and gracefully handles the other 10%.
Okay, so stepping back and looking at everything we've covered today, what are the themes?
I think one big theme is that we're seeing AI capabilities expand into genuinely high-stakes, complex domains like rare disease diagnosis, and it's being done responsibly, with human oversight and validation. That's really encouraging.
Yeah, and we're seeing the creation of better benchmarks like LifeSciBench that are designed to actually measure real-world usefulness rather than just general capability. That's important for moving the field forward.
Another theme is the continued importance of transparency. The Fugu situation is a good example of what happens when claims aren't backed up by clear, reproducible benchmarking. The community pushes back, and rightfully so.
And then on the coding and agent front, we're in this really dynamic period where multiple products are competing hard, they each have different strengths, and capabilities are expanding rapidly. Like the Vercel deployment example, that's the kind of thing that would have seemed like science fiction a year ago, and now it just works.
Right, and I think there's a question of how quickly people update their mental models. Like if you tried to do something with an AI agent 6 months ago and it failed, you might assume it still can't do that thing. But the rate of improvement is so high that you really need to keep testing the boundaries.
Yes, and that's why that advice to just try delegating every test to Codex first is actually pretty good. Not because it will always work, but because you need to calibrate your sense of what's possible, and the only way to do that is to keep testing.
Agreed. And then the local versus cloud question is interesting. We're at a point where open weight models like GLM 5.2 are genuinely competitive with frontier closed models on certain tasks, but the cost and operational complexity means it's not a slam dunk choice. It really depends on your specific needs.
Yeah, I think for most people, most of the time, cloud APIs are still the move. But if you have specific requirements around data privacy, or you want to do extensive fine-tuning, or you want guaranteed availability, or you're just really excited about the technology you want to play with it, local is a viable option now in a way it wasn't a year ago.
And hardware prices going up is interesting because it suggests strong demand. Like if Mac Studios with high memory are becoming unavailable and reselling for triple the original price, there are a lot of people who've decided local inference is worth investing in.
Although I wonder how much of that is speculation versus actual use. Like, are people buying these expecting to use them, or are they buying them expecting to flip them for profit?
Probably some of both, but I think there's definitely real demand from companies that want to run models on premises for security reasons, researchers who need control over the inference process, and enthusiasts who just want to have the capability.
Fair enough. Okay, zooming out to the biggest picture, I think what's striking about today's news is how much the use cases are maturing. We're not just talking about chatbots and summarization anymore. We're talking about AI helping diagnose rare diseases, autonomously deploying web applications, routing intelligently between models to optimize cost and performance. These are genuinely sophisticated applications.
And the infrastructure is maturing too. Better agent recovery, more thoughtful benchmarking, improved tooling for developers. It's less about, wow, look what it can do in a demo, and more about here's how it works reliably in production.
Which is what you want to see. The hype phase was useful for getting attention and investment, but the real value comes from building reliable systems that people can actually depend on.
Exactly. And I think we're in this interesting transition, where for some use cases, AI tools are already indispensable. Like developers using coding assistants are just more productive, full stop. But for other use cases, we're still figuring out the right way to integrate AI so that it's genuinely helpful rather than just a gimmick.
Right. And the rare disease diagnosis work is a great example of getting the integration right. It's not trying to replace doctors. It's augmenting their capability to process and reason about complex, fragmented evidence. That's a much more realistic and useful framing than AI will replace medical professionals or whatever.
Agreed. And it's going to be interesting to see how that model gets applied to other complex domains. Like, could you use similar approaches for legal research, for investigative journalism, for scientific literature review? There are a lot of domains where experts are bottlenecked by the sheer volume of information they need to process.
Oh, absolutely. Any field where there's a massive amount of specialized literature, where knowledge is constantly evolving, and where you need to synthesize across multiple sources to form conclusions, that's a potential application area for this kind of deep reasoning AI.
And the key is going to be keeping the human in the loop in a meaningful way, not just as a rubber stamp, but as the actual decision maker who's using AI-generated hypotheses and analysis as input to their own reasoning process.
Yes, because the expertise isn't just in knowing facts, it's in knowing which facts matter, how they relate to each other, and what conclusions you can actually draw from incomplete information. That judgment is still very much a human thing.
For now, anyway.
Well, yes, for now. But I think we're a ways away from AI that has the kind of contextual judgment and value alignment that you need to fully automate high-stakes decisions. And honestly, I don't think that's even the goal for most of these applications. It's about augmentation, not replacement.
Agreed. Okay, I think we should wrap up. This has been a really interesting episode. We covered some genuinely important applications of AI, some controversy around transparency and benchmarking, and some tactical advice for developers about how to use these tools more effectively.
Yeah, good spread. And I think the big takeaway is that the field is maturing. We're getting better at building useful applications, we're getting better at measuring real-world performance, and we're getting better at identifying and calling out hype versus substance.
Which is healthy. We need that critical perspective to separate the genuinely useful developments from the noise.
Absolutely. All right, if you enjoyed this episode, make sure you're subscribed to Semper AI Digest wherever you get your podcasts. Share it with a friend who's trying to keep up with what's actually happening in AI.
And if you've got thoughts on anything we covered today, the rare disease work, the Fugu controversy, the coding assistant wars, local versus cloud, we'd love to hear from you. You can find us at Semper AI.
Thanks for listening, everyone. We'll see you next time.
See you next time.